Okay, for the final question of the homework, question 3. This was again a standard Suvat, but then again about an object projected upwards on the top of a tower 70 metre high, and it reaches its highest point of its path after 2.5 seconds. So we have a tower which is 70 metres high, and we know that the initial projection of the object upwards is we don't know what the initial projection is, but we know after 2.5 seconds it's reached its maximum height, okay? And we have to show that the initial projection is 24.5 meters per second. In a question like this, we can't use the fact that we're given 24.5. We have to show that is what it is using the information we've got from the immediate part of the question. Well, we do know that acceleration always acts downwards, so that's acting downwards at 9.8 meters per second every second. And what we need to remember, when it reaches the top of its greatest height, its final velocity will be 0, because it'll instantaneously stop and then start dropping towards Earth. So when we write our Suvat, and it's a little tip to remember that with objects that reach their greatest height, U is what we want, V would be 0 at its greatest height, A is minus 9.8 and T is 2.5. So we've got V, A and T we want U, so that's V equals U plus AT. Subbing in, 0 will equal U plus minus 9.8 lots of 2.5. And that would obviously give you U is equal to 0 is equal to U minus 24.5, which means U is equal to 24.5 meters per second. It's hence proven without having to use any of the information you initially given. B, find the height of the stone A at 4 seconds after projection. So for part B, again, this is a Suvat, but we can then do, we know that T is then 4. So again, T is 4, A is 9.8, U is 24.5, and we want to know what the speed is after 4 seconds, so that's what we're after. And again, that would appear to just be, the height of the stone, sorry, is what we want. So we don't want V, we want height. So we've got U, A and T, and we want S. So S is equal to UT plus half AT squared. So if you're subbing in, S will equal 24.5 lots of 4 plus a half of minus 0.8 times 4 squared. Okay, and then when you follow that calculation through, you should get a value of S equaling 19.6 meters, and because it's positive, that means it's above the height of the tower. Finally, it then says calculate the speed of the stone when it reaches the ground. So for part C, we have another Suvat, the speed of the stone when it reaches the ground. So what we know now is, if we write Suvat, remember about displacement, it's from a fixed point, so our displacement will be minus 70. U is still 24.5 upwards. V is what we want, A is minus 9.8, and we don't know what T is. So here I think we've got a case of V squared equals U squared plus 2AS. So V squared is what we want, U squared will be 24.5 squared plus 2 lots of minus 9.8 times minus 70. That's where a lot of mistakes were made with the negatives. And that should give you a value of V squared to be 1972.25. Square rooting V is 44.4 meters per second.